Hello, good evening, and welcome to the another session. And then we'll start here from question number 36 of this series, 100 problems for JEE Advanced. So let's go ahead. So here we are given a differential equation and y dash of x. Let me write down with the standard notation. It will be better. So dy over dx into this is g of x, and then minus y will remain as it is. And then again we have here g dash of x, and then plus y square is equal to 0. Now this looks like the linear differential equation, but only problem is here the presence of g of x. So we will divide throughout by g of x, which means I have dy over dx minus y g dash of x over g of x is equal to minus y square into g of x. Now this turns out to be the Bernoulli's differential equation. And presence of this y square makes this Bernoulli because after all this part on the right side has to be completely function of x, but it is not. So we'll divide by minus y square. So I'll be having here minus 1 over y square dy over dx plus g dash of x into g of x, then here 1 over y will survive, is equal to 1 over g of x. Now let's call this equation some star. So we will now put this 1 over y is equal to some other variable, let's say v. So therefore minus 1 over y square into dy over dx is equal to dv over dx. Now I can resubstitute this, and this gives me dv over dx, and then plus g dash of x over g of x into v is equal to 1 over g of x. Now this is complete LD of order 1 and degree 1. Now we can solve this by finding the integrating factor. So this part turns out to be my p. So integrating factor would be e to the power integration of p dx, which is integral of g dash over g of x. And this gives me e to the power ln of g of x, which is simply g of x. Now let's go ahead. So therefore, this is here the dependent variable is v. So the solution would be given by v into integrating factor is equal to integration of the thing on the right side will be called as the q into the integrating factor dx plus some constant. So now if I find out the solution, so v into integrating factor is g of x itself. So I'll be having here v into g of x is equal to integral of g of x, and on the right side we have again g of x 1 over. So these two part gets cancelled. So I'm left with v into g of x is equal to x plus c, and v is nothing but 1 over y into g of x is equal to x plus c. So it is given to us y of 1 is given to be 1 and g of 1 is 0. So in this equation we'll plug in x is equal to 1. So I now have g of 1 over y of 1 is equal to 1 plus c, and g of 1 is given to be 0, which means my this side becomes 0. So c will be equal to minus 1. So c is minus 1. Again, I can plug in here. So this implies I get g of x over y of x is equal to x minus 1. And that's what we get. So now what is required? Y of 2. So when y of 2 is required, I can just set here x is equal to 2, which means g of 2 over y of 2 is equal to 2 minus 1. So this implies g of 2 is same as y of 2, and g of 2 is given to us, that is 4. So this value turns out to be 4. So y of 2 will be 4. Now let's go for the second one. So it asks us to find the integration from 1 to 2. So for the second part, integral 1 to 2 g of x into y of x into 1 over x squared into 1 over x squared into square root of x squared plus Again, g of x over y of x squared. G of x over y of x being square and then dx. So I'll be simply just plug in all the values. So 1 to 2, this is nothing but my x minus 1. So this over 1 here, x square, and then square root of x square plus x minus 1 square. For this I need to solve. So integral 1 to 2, x minus 1. And here this is x square simply. Then square root of this is x square plus x square is 2x squared. And then minus 2x. And then plus 1. Now, this is x squared and x squared. So I can think of taking x squared common from the square root part. And this leads to 1 to 2, x minus 1. This will be x cube here. And in the square root, I get 2 minus, this will be 2 over x, which is x power minus 1 plus x power minus 2. And now if I keep this one here, so I'll be having here integral 1 to 2. Let's divide by x cube, which this gives me x power minus 2 minus x power minus 3. And then in the denominator, I have here 2 minus 2 times x to the power minus 1 plus x power minus 2. That's what we have. If I see, okay, we can do one thing. We can keep this entire root as some substitutions. Say 2 minus 2 power x minus minus 1 plus x power minus 2 is equal to some t. So if I have this thing, I'll think of differentiating because I have a gut feeling that this will turn out to be the derivative looking at the powers. So differentiating with respect to x. So once I differentiate, I get this is 0, and then minus of minus will become plus here, and then I get 2x power minus 2. And this would be minus 2 here, and then again x power minus 3. This is in the square root, so rather it will be better if you plug in t square instead of t, so that we can have here 2t dt, then square root will be gone directly. So I get x to the power minus 2 minus x to the power minus 3 into dx. Okay, this is dx, of course, is equal to t dt. So now we need to change the limits. So when x is 1, I can just plug in here 2 minus 2, which is 0, and then 1. So t square is going to get here. And then when it's going from 1 to 2, that means I have to take the positive one. So this is 1. And then when I plug in here 2, I get here 2 minus 2. This is gone. 2, no, this is 1. 1 plus 1 over 2 will give me 5 over 2. So 5 over, no, this is 5 over 4 basically. Because this part will be 2 minus 2 over 2 plus 1 over 4. So this will be 4 plus 1, 5 by 4. Yeah, perfect. So 5 over 4 it would become, and then when I take the square root, it will become plus. So I can write down here root of 5 over 2. And then simply t into dt over, this is square root is t square. So this directly gets cancelled, and I get here root of 5 over 2 minus. So the answer to the second part is root of 5 over 2 minus 1. And this completes question number 36. Let's go to the next problem, question number 37. Okay. We have f of x is a 2-degree monic polynomial. 2-degree monic polynomial means my f of x starts with x square kind of thing. That means the coefficient of x square is 1. And then we have here next information, that is minima at x is equal to minus 3, and the minimum value is minus 8. So if it has minima at x is equal to minus 3, that means this would look like x plus 3 the whole square, and minimum value is minus 8. That means I have the equation to be this. So f of x will be what? X plus 3 square minus 8. Now if you see here, then this has minima at x is equal to minus 3, and the minimum value is minus 8. So we have constructed the polynomial, and now we need to break this down. So we have x squared plus 6x, then 9 minus 8 is plus 1. So I have f of x to be this. Now, what's the next line? That S denotes the set of points x, y in the coordinate plane such that f of x plus f of y is negative. So if I do this, f of x plus f of y to be less than or equal to 0, which means I now have x squared plus 6x plus 1 plus y squared plus 6y plus 1 less than or equal to 0. So I'll think of collecting x square family together and y square family together. Family means I just mean all x terms together, not the original family. So plus 9 here, plus 9 here, less than or equal to 9 plus 9, 18, and then this 1 and minus 1 will give me 16. So that means my equation will look like this: x plus 3 square plus y plus 3 square will be less than or equal to 4. So this is 1, and then we also have f of x minus f of y. So for f of x minus f of y, I'll be having x square plus 6x plus 1 minus y square plus 6y plus 1 is less than or equal to 0. So this one gets cancelled, and then x square minus y square plus 6 times x minus y will be here, less than or equal to 0. So I'll just think of factorizing this guy. So I'll be having x minus y into x plus y, and then plus 6 times x minus y is less than or equal to 0. So I can think of taking this guy common. So I have x minus y into x plus y plus 6 is less than or equal to 0. So we have the other line. This is joint equation of two lines. One is passing through the origin and another one is not passing through the origin. But anyway, that has nothing to do with our question, because ultimately we need to find the region here. So no, we don't need the region. We need the area of this S. S is what? The one which satisfies this thing. So if we plot it, okay, say I have a circle here. What's the coordinate system? So center is at -3, -3. This is my circle, would go somewhat like this. Apologies, very bad at drawing. So in that, this is my circle, and then we have the line x minus y, which means the line is going to be that line here. Y is equal to x line, and x plus y plus 6 is equal to 0. So y is equal to x line would be, of course, like this. This is my y is equal to x line, and x plus y plus 6. So x plus y plus 6 would be 6 units above. Means this would pass through. And by the way, if you notice, then center is -3, -3, and my line is passing through this. So my line is again passing through this also. So now what do we want is, we want the area of that region which is lying between these two lines. So if you see the region between these two lines, which means this is x minus y and then x plus y plus 6. So I can just divide by, no, there is no point, x minus y into x plus y. That means this is lying between these two lines. That means if I take a point between these two, so it should lie above one line and below this line, or any one of them. So we have to see the region which is above. That means I'll have this one is x plus y plus 6 is equal to 0. So my point, if I take this region, then this is below this line, above this line. So okay. And if I take this region, then this is above both the lines. That means here, this is not going to be the region. My region is going to be, first of all, it should be inside the circle and it should be between these two lines. So my region would be here somewhere. This one and then this one. So this diagram I need. I need the area of this region. So if we see the symmetry, then this looks like, by symmetry, this line is passing through the diameter. This line is passing through the center. That means this can act as one of the diameter. So, and this area will be same as this area. So what we can do is, we can find the half of this area, and then suppose instead of finding this total area, I think of moving this line a bit down. So the moment I move my line like this portion would be covered here actually. That means I'm basically finding the half of this semicircle, half of this circle, which is semicircle. So therefore, the area of region S, so area of region S would be just simply half of pi and then r square. Yes, it is going to be half of pi square. Yeah. Circle is 16 here, so that's going to be 16. So the area is going to be basically 8 pi. So if this 8 pi is solved, now we have the another monster waiting for us. So from n is equal for n is equal to 1 to infinity, if I just plug in here all these things, let us see what do we get. So lambda is 8 pi. So 8 pi by 8 will give me pi minus, if I take minus common. Okay, so if you watch carefully, then sec inverse of this is square root of this positive quantity. So this entire thing is positive and then plus 1. And we know that sec inverse domain. Sec inverse of x, that means my x belong to what? Minus infinity to minus 1, union 1 to infinity for x. Okay, the domain is this. That means this is quite more than 1, definitely. So this quantity is more than 1, this is also more than 1. That means, and these two are theta. So if we call this as theta, this is again theta. So sec inverse theta plus cosec inverse theta. That just simply turns out to be pi over 2. This over pi into a to the power n. And now this can be further written as n is equal to 1 to infinity. Pi minus pi by 2 is going to be pi over 2a pi to the power n. So this pi gets cancelled. That means my series is basically 1 over 2a to the power n and runs from 1 and then goes up to infinity. Now we are saying that this sum is finite. So if this sum is finite, that means the common ratio, which is 1 over 2n, this common ratio should be less than 1 because that's a geometric series. And the sum is finite, that means series is convergent. So the series is convergent only when the common ratio is less than 1. So now what is next? So given that a is positive, so I'll consider only the first part. That means 1 over 2a is going to be less than 1. Because there is no point of taking this negative. So we'll transfer this one here. So 1 over a is going to be less than 2. That means a is going to be more than, it's going to be more than half. 1 over a is less than 2. So a is more than half. So we have this part. And now we are saying that a is more than 0. So let me think of opening this thing. Wait a moment. If I open with modulus, what do I get? It will be minus 1 less than 1 by 2a is less than 1. Okay, so positive part is required. That means only this one. So 1 over 2a should be less than 1. So that means 1 over a is less than 2a multiplied. Take the reciprocal. So a will be more than 1 by 2. So a is positive. That means a belongs to what? Half to infinity. So this is the set of all the values of a for which we get the sum of this series to be finite. Now this completes our problem. Let's move to the next one, question number 38. Yeah. So we have f of x is equal to x square and g1 of x is f of x. That means g1 of x is simply again x square and gn plus 1, and this starts from 2 basically. So that means I'll be finding g2 here. So g2 of x would be minimum of 0 less than or equal to t less than or equal to x, and g1 is going to be x square plus f of x minus t will be x minus t square. So now I'll simplify this expression. So this is x square plus x square minus 2xt plus t square. This would be written as 2x square minus 2xt plus t square. Oh no, this is gn of t basically. That means I have to write down here t square, not x square. Okay, strange. This is given to be g1 of t. So g1 of t is going to be f of t. F of t is nothing but t square. So t square plus x minus t square. Now if I open this, I get here t square plus x square minus 2xt plus t square. This gives me 2t square minus 2xt plus x square. So we need to find the minimum, and the variable here is t. So we'll treat t as variable and x as constant for this one. Let's keep 2 outside. So t square minus xt. Then I'll be adding here plus half, that's x square over 4. And also I'll subtract x square by 2 plus x square. So this means I get here 2 times t minus x by 2 square and then plus x square by 2. This could be written as minimum of 0 is less than or equal to t less than or equal to x, and then I get here 2 times t minus x by 2 square plus x square by 2. So my t is varying between 0 to x, so this quantity will be minimum. So minimum here is x square over 2. That means my g2 of x is going to be x square over 2. Similarly, we'll find out g3. So g3 of x is going to be minimum of 0 less than or equal to t less than or equal to x. Again, now we need to take here g2 of t. So g2 of t will be t square over 2 plus x minus t the whole square again. So if we consider this expression, so I'll be writing here t square over 2 plus x square minus 2xt plus t square. So which means I now have 2 plus 1, 3t square over 2 minus 2xt plus x square. So we now need to simplify this guy. So for that, we'll take 3 over 2 outside, and then again t square minus, this is 2xt. So we have taken 2 over, that means 3 would be down here. Then this will become 4xt. And then what is left here? Plus x square. So I need to add 4xt, that means half into coefficient is 4x over 3, which means I'll be adding here 4x square over 9 and subtracting. So this is 2, so minus 2x square, and then 3 is this. Okay, and then plus x square. So this is 3 over 2 times t minus 2x by 3 square, and then 3 minus 2 is plus x square over 3. So the minimum I want, and again the variable here is t only, so minimum turns out to be, minimum will be x square over 3, which turns out to be at 2x by 3. So this is x square over 3. That means now we can be assured that we have got the sequence which gives us the minimum. So if we continue in the same direction, then we'll be having here gn of x is equal to 1 over root of n into not x square over n, basically 1 over x square by x square over n. So gn of x is simply x square over n. Because for 2 we're getting 2, for 3 we're getting 3. So for n I should get x square over n, the common sense. And then now we need gn of 1 over root n plus 1. So gn of 1 over root of n plus 1 will give me 1 over n, and this will be squared, so I get here n plus 1. Now we need to add it from n is equal to 1 to 2026. So 1 to 2026, I'll be having here 1 over n into n plus 1. Now this can be expressed as a telescope, so n is equal to 1 to 2026 with 1 minus 1. So this is being telescoped. Now plug in the lowest value here and the highest value here. So this will be 2027. So this gives me 2026 over 2027. So this is my lambda. And now I need here GF of 1 by lambda. So therefore 1 by lambda would be 2027 over 2026. So if I take its GIF, I get here simply 1. So the answer here is going to be 1. Let's go for the next one. We'll go for this one. And now what do we have is f of x is given to be this monster product. And the product of all real roots of f of x is equal to 0 is m factorial given. And let g be a function. So this is basically a sequence from n to n satisfying this thing. And Sn is given to be this. So value of S9 plus m over 47 root pi. All right. So let's go ahead. So f of x would be simply, if I plug in k equal to 1, I get here x square minus 12x plus 1 into e to the power sine x minus e to the power minus sine x minus 4. Okay, this is product here. All right, anyway, f of x is equal to 0, we are writing. So there is no point of writing anything here, because ultimately all of them will be multiplied. So I can leave here k only. This over this thing being multiplied. So x square plus x plus 2 to the power 2k. This is equal to what? 0. So this is going to be total product. It's going to be 0. So now let's see here. What do we get? So first of all, we see that this guy has no real root. That means I can send this to the other edge. So this is gone completely. It doesn't matter how many times it is present. So this is gone. And then the next guy is this one. So e to the power sine x minus e to the power minus sine x minus 4 is equal to 0. Let's consider this thing. So I can take this to be t. So e power sine x is equal to what? T. So this means I have here t minus 1 over t minus 4 is equal to 0. So I can now write down t square minus 4t minus 1 is equal to 0. T square minus 40, yes. So t square minus 4t minus 1 is equal to 0. So t is equal to 4 plus or minus, this is going to be 16. T square minus 16 plus 4ac is 4. 4ac over 2. So I'm going to get here 4 plus or minus 16 plus 4 is 20, which is 2 root 5 over 2. And this gives me 2 plus or minus root 5. So t is equal to this. And now we need to see where this t belongs to. So my sin x belongs to minus 1 to 1. So my e to the power sin x will belong to e to the power minus 1 to e. So that means this quantity is even e to the power minus 1 to e, and e value is 2.7183. And this crosses this thing. So that means there is no solution for this guy also. So this also has no solution. So when this guy has no solution, which means now survives is this guy, x square minus 12x plus k. So the product x square minus 12x plus k is equal to 0 has no real roots. So that means here b square minus 4ac must be negative. No, sorry. All real roots we want, not real roots. Complex. So that means b square minus 4ac must be greater than or equal to 0. If this want to have a real root, so we will see for how many value of k this has. 6. Okay. So start this thing. So that means 144 minus 4k is going to be greater than or equal to 0. That means 4k is going to be less than or equal to 144. So k is going to be 4 3s are 12. 4. So 6 are 24. Less than or equal to 36. So that means f will have it will go only up to 36. So which means I'll be writing like this: x square minus 12x plus 1 into x square minus 12x plus 2 into x square minus 12x plus 3 and so on up to x square minus 12x plus 36, and rest all of them will have complex roots, so they will go away. And now we want the product of all real roots. So product of all real roots here is going to be, this is 1, and then this is 2 into 3 into 4 and so on up to 36, which is nothing but 36 factorial. So that means my m value is 36. So therefore m is equal to 36. Now the next part is we have here a function g which satisfies this thing. Let's see now. So for g, if we are concerned, then g is from natural to natural, and this satisfies g of n plus g of n plus g of n is equal to 3n. So this is a sequence basically from natural to natural, and we see here this is 3n written. So 3n we can split it this way. 3n could be written as n plus n plus n. 3 times n plus n plus n. So now if you notice here, okay, so if I take g of n is equal to n, then g of n is going to be n again. So g of n is going to be again n, and this is also going to be n. So that means my g of n is equal to n satisfies this part. So if I have this guy, g of n, then what is pending there? SA g of k cube. So SA is going to be sigma k is equal to 1 to n. So simply going to be k cube. So which is n square into n plus 1 square by 4. So this is my S10. I want S9. So S9 will be 9 square into 10 square by 4. So this will be simply, this is 9 square, 10 can be written as 2 square into 5 square over 4. These two go away, and then we get here 5 into 9 is 45 square, which turns out to be 2025. So now if I plug in all these values here, then I get here GIF of 2025 plus this is 36 over 47 root pi, which is a negligible value between 0 to 1. So the answer will be simply 2025. This is going to be 2025. No. So that's all. We'll continue again in the next session. Thank you so much. Happy learning. Bye bye.